Hello, my name is Jose Luis Mela, and I am a PhD student at the Universidad Computational de Madrid, and I would like to thank you for the opportunity to present my work at the International Conference Computational and Mathematical Methods in Science and Engineering. In the following minutes in the presentation, I will be talking about this paper with this focus on the YOLO model comparison for maritime vision on Jackson AGX ORI performance versus energy trade-off. In this presentation, I will be talking a little about the problem and motivation for this work, then the objective of research, the methodology, then result from the training phase, then the evaluate on different model, then using multi-criteria analysis based on machine learning to determine the most optimal model in performance in the process of inference and energy consumption, and finally the finding and future lines of research. So today we can find many studies related to the development and optimization of neuronal models in the maritime context, where they mention to different challenges more that are related to environment itself, for example, and weather conditions like waves, fog, and water reflection, and different object sites. In this context, USB models require high efficiency. However, the device have limited energy resource, which affects or impact the level of confidence in object detection. Because of this work, this study seeks to make a systematic evaluation of YOLO architecture, balancing detection accuracy, inference speed, and power consumption for maritime edge deployment. So, the objective for this study are basically to make a comparison of the 5 model of YOLO VH and YOLO 12. Then, the evaluate performance of these models, different power models on the AGX ORI and at different precision. And finally, be machine learning to determine the best 5 models based on efficiency and power and performance criteria. So for this study, we have used a dataset that we already used in a previous study, which has about 10,000 images, including different class, for example, like bulk carrier, cruise ship, fishing boat, and other class. So, in the training phase, we use the 2 GPU, like Tesla V100 and 830. We set the training fixed 150 epochs and 2 versions, the YOLO, specifically YOLO VH and YOLO 12. So the edge deployment phase, we use the Jackson AGX ORI and their power model confusion and different precision. Based on the test performance in this slide, I show the overall result of each model variants on each GPU according to the metric, for example, precision, recall, and training time. So we can see a very similar behavior between the YOLO VH and YOLO 12, the same version, where the YOLO version requires between 21 to 28 less training time. As well, we can see the time for the same variants between both GPUs. The 830 takes less time. This is because of the basic Ampere architecture, which is more efficient. In this work, to make a more complete analysis, because there are multiple models of energy and precision, we choose all the models that were training on the GPU. And we fixed some criteria for this framework, where the idea was to find a top 5 best model. The 5 criteria is based on the fair equal evaluation of performance, power, and latency. The second criterion focus on performance, giving a percent to FPS, for example, 40%, efficiently 20%, and latency and power and change different values. The efficiency criteria, we focus more on the energy part, and finally, the Pareto optimal analysis, we identify non-dominant solution for optimal trade-off. So in this way, we can see in this slide the model is in each graph for each criteria. The YOLO VH model are the best performing. And continuing with the analysis, we have been able to determine the model, the optimal model, based on the energy and precision setting. We can see that the model for the YOLO VH Nano is the better or more suitable for deployment in the system vision. So according to the test for the performance metric, there are no significant difference. But YOLO VH is the better solution in the different size that the YOLO 12 require more training time and memory capacity, because for GPU at 24 gigabyte, and we found the error CUDA memory out. Based on the analysis of the criteria for this framework, the optimal model is YOLO VH Nano, and these criteria allow us to have a visualization of the scenario where we want to deploy the model, because we can play with the percent given to each condition. With this result, we contribute to determine based on the data which is the best solution, which model to use in the edge system. And finally, as the future work, we would like to explore the earliest techniques, replicate this study with other dataset, evaluate the models on other platforms like Intel or Google, and come up with a framework that selects the model and configuration of the edge devices based on the condition, climatic condition or workloads, for example. And finally, well, thank you very much. Any question, I am at your disposal, and again, thank you so much.